Hello, and welcome to Students Fast Review, here with AP Calc AB and BC, Unit 3. This is more differentiation rules. So let's start by looking at the chain rule. So the chain rule is we're taking the derivative of a composite function, and that just means the function of a function, so f of g of x. So let's look at this cosine of x squared. So the f of x, or the outermost, is cosine of x, while the innermost would just be x squared. Looking at this next example, ln of 3x squared plus 1. So the f of x, or the outermost, is just ln of x, while the inside is 3x squared plus 1. Looking at this last example, the outermost part of the function would just be x squared, meanwhile the inside would just be sine of x. So now, let's look at what the chain rule states. So the chain rule states that we're taking the derivative of a composite function, that it's the derivative of the outside of the inside, so leaving it be, times the derivative of the inside. So looking at this first example, cosine of x squared. So to take the derivative, you take the derivative of the outside, so it'd be negative sine, and leaving the inside be x squared times the derivative of the inside, which is 2x. Now looking at this next example, the derivative of ln is 1 over the inside, so it'd be 3x squared plus 1 times the derivative of the inside, which is 6x. In this last example, the derivative of the outside is 2 times the inside, sine of x, multiplied by the derivative of the inside, which is just cosine of x. So now let's look at implicit differentiation. So what that means is we're taking the derivative of an implicit function, and that just means when the y isn't explicitly solved for, or when it's in both sides of the equation, like this. So to do implicit differentiation, what you do is you take the derivative of x as normal, but you also do the same thing for y. So you take the derivative of y, and you gotta multiply that by a dy dx. So looking at this example here, what you would do, you take the derivative of x as normal, so that'll become 2x, plus taking the derivative of this y will get you 3y squared, multiply it by dy dx, and then is equal to 4 dy dx. You can also write this, the dy dx, as y prime, if that's easier. So now, let's look at a better example. So let's solve for dy dx. So to do that, you take the derivative, so this would be 3y squared dy dx plus 4x is equal to 3 plus dy dx. And now you move this dy dx to the other side of the equation so that they're all together. So you get 3y squared dy dx minus dy dx. And you move this 4x to the other side, so you get 3 minus 4x. Now you have a common factor of dy dx, which you can take out, so you get dy dx times this 3y squared minus 1 is equal to 3 minus 4x. And then you can solve for it, so you get dy dx is equal to 3 minus 4y, or 4x over 3y squared minus 1. So now, let's look at differentiating inverse functions. So an inverse function is just when the x and y are swapped. So the derivative of the inverse function is 1 over f prime of f inverse of x. So looking at a table, here we have to find g prime of 1, and it's stated that g of x is the inverse of f of x. So now, looking at this, we have f inverse of 1. So here, is equal to 2. So now looking back at the equation, you can plug that in. So you'd say 1 over f prime of f inverse of 1, which is really 1 over f prime of this 2, which will just be 1 over negative 4. So now let's look at inverse trig. So with inverse trig, these need to be memorized, but the most important ones is definitely on this side. So sine inverse, cosine inverse, and tan inverse. So here we have sine inverse of x is just 1 over the square root of 1 minus x squared, while the inverse of cosine is just negative of that. And then the derivative of tan inverse is just 1 over 1 plus x squared. And then cotan is just the negative of the inverse of tan. And here we have cosecant inverse and secant inverse, and they're just negatives of each other. And cosecant would be negative 1 over the absolute value of x times the square root of x squared minus 1. And secant inverse would just be positive of that. So now let's look at selecting procedures for calculating derivatives. So this just means what do you have to do to take the derivative. So as you can see, there's power rule, trig, product, quotient, and chain. And most of the time, you're going to have to do the chain rule first, just because it's the outermost part, and then you would use these other rules alongside it. So now let's look at higher order derivatives. So what that means is when you're taking the derivative multiple times, and what you'll see a lot of the times is this term twice differentiable, and that just means that the derivative can be taken twice. And this is the most common notation. So it'd be y prime and then y double prime. Same thing, like f double prime. And then here it'll be d2y dx squared, essentially. So just doing a quick example, if you have like the derivative d over dx of, let's say, 3x squared plus x, taking the derivative once would just get you 6x plus 1, and then taking the derivative again of that would just get you 6. All right, that is all for Unit 3. Thank you for watching, and bye.